Imagine a vast, silent expanse beyond our solar system, where ancient wanderers drift through the cold void of space, occasionally veering toward our tiny blue world in a display of celestial grandeur. For centuries, humanity has gazed at the stars with a mix of wonder and curiosity, pondering whether we are truly alone, or if something or someone might be out there, silently observing our progress. The discovery of Oumuamua in 2017 marked a pivotal moment as the first confirmed interstellar object, a peculiar cigar-shaped visitor that ignited heated debates among scientists about whether it was merely a natural rock formation or perhaps an alien probe sent from distant civilizations. Following closely in 2019, 2I/Borisov emerged as a more traditional comet-like entity, complete with a visible tail, reinforcing the idea that the universe is brimming with unexpected surprises that challenge our understanding of cosmic dynamics. However, as of September 30th, 2025, the cosmos has orchestrated an even more captivating spectacle with the arrival of two remarkable visitors: the interstellar comet 3I/ATLAS, first spotted in July, and the impressive long-period comet C/2025 R2 SWAN, which made its dramatic entrance in September. While 3I/ATLAS whispers tales of origins from far-off star systems, SWAN blazes across the sky with a tale that commands attention, sparking imaginations and blending the boundaries between established science and intriguing speculation. What if these celestial nomads carry secrets beyond mere ice and dust? This narrative isn't just about distant comets. It's a thrilling exploration of discovery, the magnetic pull of the unknown, and the profound questions that compel us to keep our eyes fixed on the night sky. If you're feeling that same sense of awe and excitement that grips astronomers worldwide, go ahead and hit that like button right now, and let's embark on this extraordinary cosmic adventure together, unraveling the mysteries one star at a time. The story of this cosmic drama unfolded on a seemingly ordinary day in mid-September 2025, specifically on September 11th, when the Solar and Heliospheric Observatory (SOHO) spacecraft, a reliable sentinel dedicated to monitoring the sun and its surrounding environment, detected an unusual glow through its solar wind anisotropies SWAN instrument. Initially dismissed as potential interference or a minor fluctuation in the solar wind's constant stream, the anomaly persisted, prompting closer scrutiny from ground-based analysts who sifted through the incoming data with growing intrigue. As the information clarified, it became evident that this was no mere glitch, but the signature of a bright comet racing toward our inner solar system, its coma radiating with an unexpected intensity that set it apart from routine observations. Amateur astronomer Vladimir Bazugli, diligently reviewing the SOHO images, played a crucial role in confirming the discovery, highlighting the vital contributions of citizen scientists in modern astronomy. The International Astronomical Union acted promptly, designating the object as C/2025 R2 SWAN, a name that now evokes both scientific fascination and a touch of mystery among enthusiasts. In the days that followed, astronomers across the globe, from professional observatories to backyard setups, directed their telescopes toward this newcomer, capturing initial images that revealed a tail extending approximately 2 degrees across the sky, equivalent to about 4 times the apparent width of a full moon, making it a visually striking phenomenon that demanded further investigation and analysis. Envision yourself standing in a remote, light pollution-free field in the southern hemisphere, where the night sky unfolds in all its splendor with the Milky Way arching overhead like a luminous pathway through the cosmos. As the sun sets and twilight gives way to darkness, you train your gaze toward the western horizon, and there it materializes, C/2025 R2 SWAN, manifesting as a fuzzy, ethereal green orb accompanied by a gossamer tail composed of ionized gas and fine dust particles. By the latter part of September 2025, the comet's apparent magnitude had increased to around 6.5, rendering it accessible through small binoculars or, under ideal dark sky conditions, even to the unaided eye for those with keen vision. Dedicated observers in locations such as Wellington, New Zealand, managed to photograph the comet on September 26, depicting it positioned about 17 degrees above the horizon, with its tail appearing as a subtle, elongated streak against the fading twilight glow. Far from being a static point of light, SWAN is a vibrant, ever-changing entity. Its coma expands dynamically as the sun's radiant heat causes the embedded ices to sublimate, releasing gases that form the characteristic envelope and propel dust outward. Adding to the excitement, around October 5th, 2025, our planet is projected to intersect SWAN's meteoroid stream, which could result in a modest meteor shower where fragments of the comet incinerate in Earth's atmosphere, creating fleeting streaks of light reminiscent of a natural pyrotechnic display. If you've never had the privilege of witnessing a comet's tail in person, this presents an opportune moment. Equip yourself with binoculars, seek out a location far from city lights, and document your experiences in the comments section below. Your personal observations could very well enhance the collective pool of citizen science data, aiding researchers in tracking the comet's behavior and evolution over time. Yet SWAN does not command the celestial stage in isolation. It shares the spotlight with another intriguing visitor that has captured the attention of the astronomical community. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS telescope located in Chile, detected 3I/ATLAS, officially cataloged as C/2025N1, marking it as the third confirmed interstellar object to traverse our solar system. Unlike SWAN, which originates from the distant Oort cloud, a vast spherical shell of icy planetesimals encircling our sun at the fringes of its gravitational influence. 3I/ATLAS is a true outsider, likely ejected from another stellar system through gravitational interactions or stellar perturbations eons ago. NASA's confirmation of its interstellar status came via detailed orbital calculations, revealing a hyperbolic trajectory, indicative of an object unbound to our sun. By late September 2025, observations from the Hubble Space Telescope unveiled that this object is substantially larger than initial estimates suggested, with mass projections exceeding 33 billion tons, portraying it as a colossal interstellar wanderer hurtling through space at velocities that surpass those of solar system bodies. The inevitable comparisons between SWAN and 3I/ATLAS highlight their differences. SWAN's expansive tail contrasts sharply with the more subdued asteroid-like appearance of 3I/ATLAS, which exhibits only faint signs of cometary activity. Nevertheless, their appearances coincide in a remarkably synchronous manner. SWAN achieved its perihelion on September 12, 2025, at a distance of 0.5 astronomical units from the Sun, while 3I/ATLAS is en route to its own solar closest approach on October 29, 2025 at approximately 1.36 astronomical units. From our vantage point on Earth, these two will appear to draw near each other in the vicinity of the Sun, momentarily obscured by its intense glare, fueling a wave of discussions and theories about this apparent cosmic rendezvous. Delving into the intricacies of SWAN's trajectory reveals a narrative steeped in ancient cosmic cycles that span millennia, characterized by an eccentricity of 0.9931 and an inclination of merely 4.47 degrees relative to the ecliptic plane, the flat disk in which Earth and the other planets orbit the Sun. This comet approaches with an almost uncanny alignment, a feature that is somewhat atypical for long-period comets which frequently enter at more pronounced angles due to their origins in the isotropic Oort cloud. While such shallow inclinations are not entirely unprecedented, they add an layer of interest to SWAN's path, suggesting possible past perturbations by giant planets. Current orbital computations estimate its period at over 22,000 years, implying that its previous passage through the inner solar system occurred around 20,529 BCE, a time when early humans were navigating the tail end of the last ice age, developing rudimentary tools and beginning to form complex societies. One can only imagine our distant ancestors looking up in awe at this same brilliant streak, perhaps interpreting it as a divine sign or portent of change. As we approach October 20th, 2025, SWAN is slated to make its nearest approach to Earth at 0.26 astronomical units, equivalent to roughly 24 million miles, a comfortably safe distance that nonetheless allows for potential brightening to a magnitude of 4 or 5, making it comparable in visibility to the prominent stars of the Big Big Dipper constellation under clear skies. In stark contrast, 3I/ATLAS, with its hyperbolic eccentricity greater than 1, follows a trajectory that ensures it will not return. It is destined to swing past the sun and continue its journey back into the interstellar medium. The near simultaneous emergence of these two objects, with statistical probabilities estimated at less than 1 in 20,000, has prompted astronomers to conduct extensive Monte Carlo simulations to model random entry scenarios, ultimately affirming that while rare, such alignments can arise from the gravitational influences of outer planets like Jupiter, whose orbit intersects Swans at a minimum distance of 0.043 astronomical units, underscoring the dynamic and unpredictable nature of our solar neighborhood. With data streaming in from observatories around the world, the physical characteristics of SWAN are gradually coming into sharper focus, although certain enigmas continue to intrigue researchers given the relatively short observation window of just 38 days as of late September 2025. Preliminary spectroscopic analyses indicate a composition consistent with typical Oort cloud comets, comprising primarily water ice, carbon dioxide, methane, ammonia, and silicate dust, all of which sublimate under the intensifying solar radiation to generate the observed coma and tail structures. Contrary to some circulating online rumors, no anomalous metallic signatures such as isolated nickel vapor or deficiencies in iron have been substantiated. Rather, the comet's rapid surge in brightness, from magnitude 11 in August to 6.2 by mid-September, can be attributed to episodic outbursts where subsurface ices are suddenly exposed and volatilize, releasing copious amounts of gas and dust in short bursts. The distinctive greenish tint of Swan's coma arises from the fluorescence of diatomic carbon molecules excited by ultraviolet light from the sun, a common phenomenon that imparts an almost otherworldly aesthetic to the object, reminiscent of depictions in science fiction. On the other hand, 3I/ATLAS displays more restrained activity, with infrared observations detecting subtle outgassing that corresponds to an energy output on the order of 10 to 15 gigawatts, a level entirely consistent with the natural heating and sublimation processes expected for a cometary nucleus approaching the sun, devoid of any indications of artificial propulsion or modulated thrust. These findings underscore the natural origins of both visitors, yet their unique attributes continue to inspire deeper investigations into the diversity of cometary bodies and the processes that shape them across interstellar distances. The human propensity for weaving narratives around the unknown has turned the arrivals of SWAN and 3I/ATLAS into a global phenomenon, with the internet serving as a fertile ground for a diverse array of theories that blend verifiable science with imaginative conjecture. Harvard astrophysicist Avi Loeb, renowned for his provocative hypotheses regarding previous interstellar objects like Oumuamua, commented on September 15, 2025, highlighting that Swan's approach from the direction of Aquarius and 3I/ATLAS's from Sagittarius, separated by several tens of degrees, effectively eliminates any plausible direct linkage, such as one being a fragment or companion of the other. Nevertheless, Loeb's broader explorations into the possibility of interstellar objects bearing technological signatures have invigorated discussions, prompting online communities to speculate whether SWAN's precise alignment with the ecliptic plane might suggest intentional navigation, or if the temporal proximity to 3I/ATLAS hints at a clandestine interstellar rendezvous concealed within the sun's blinding corona. Conspiracy-oriented forums have amplified claims of advanced features like protective plasma shields, engineered cores enriched with purified nickel, or even rhythmic pulses and infrared wavelengths that mimic prime number sequences, evoking the protocols proposed by SETI for detecting intelligent signals. A notable post dated September 30th, 2025, metaphorically describes Swan as a plasma fortress, overshadowing 3I/ATLAS's scout drone, while others draw parallels to ancient myths or hypothetical alien surveillance missions. High-profile individuals, including entrepreneurs and politicians, have contributed to the discourse, sometimes with humorous or cautionary remarks that further propel the viral spread of these ideas. However, the scientific consensus remains steadfast. These are natural cometary bodies, albeit exceptional ones, and while speculation adds to the excitement, it must be tempered by empirical evidence and rigorous analysis to avoid veering into unsubstantiated territory. The calculated 22,554-year orbital period of Swan not only projects its future returns, but also invites intriguing reflections on its historical passages, stirring connections between astronomy and archaeology that captivate both scholars and the public. This periodicity positions its most recent prior visit at the cusp of the last ice age's conclusion, a transformative era in human history marked by rapid environmental shifts, the extinction of megafauna, and the nascent development of settled communities that laid the groundwork for civilization. Archaeologists and alternative historians alike have noted alignments in ancient structures, such as the enigmatic temple complex at Göbekli Tepe in Turkey, dating back over 11,000 years and adorned with intricate carvings that some interpret as astronomical notations, or the precisely oriented shafts of the Great Pyramid of Giza, which point toward key constellations like Orion's Belt. Theorists like Graham Hancock propose that such sites might reflect influences from celestial events, suggesting that a brilliant apparition like SWAN could have been perceived as a sky god or catalyst for cultural advancements in agriculture, mathematics, and celestial mapping, as echoed in global myths depicting fire-tailed serpents or radiant beings descending from the heavens. While mainstream academia largely regards these linkages as coincidental or products of confirmation bias, the temporal overlap cannot be entirely dismissed, prompting interdisciplinary dialogues that explore how ancient sky watchers might have documented and ritualized such rare events. In this light, SWAN's return feels like a bridge across time, reconnecting modern observers with our ancestors' shared sense of wonder, and perhaps inspiring new interpretations of humanity's enduring fascination with the stars. As Swan advances toward its maximum visibility in October 2025, it joins forces with another celestial highlight, Comet C/2025A6 Lemon, which is anticipated to brighten to a magnitude of 2 to 4, potentially creating a rare triple comet display alongside the lingering presence of 3I/ATLAS in the background. Reports of anomalous signals, pulses, or military mobilizations, such as redirects of classified satellites or launches of the X-37B space plane, remain unverified and likely stem from over-enthusiastic interpretations rather than concrete evidence, with agencies like the US Space Force and Navy conducting standard surveillance of near-Earth objects without any declared emergencies. Instead, the genuine allure resides in the opportunity for public engagement. Platforms and apps like the Comet Observation Database, COBS, empower everyday astronomers to submit brightness measurements, tail descriptions, and positional data, fostering a collaborative effort that enriches scientific databases and democratizes discovery. Should Swan endure its perihelion passage intact, a challenge for pristine Oort cloud comets prone to fragmentation under intense solar heating, it will gradually diminish in brightness, bequeathing a legacy of observational data that could inform future models of cometary evolution and solar system dynamics. Meanwhile, its modeled trajectory, which includes close approaches to Mars, Venus, and eventually Jupiter, appears almost artfully precise, akin to threading a needle through the vastness of space, though this can be fully accounted for by the inexorable laws of gravity and orbital mechanics, with probabilities, while slim, falling within the realm of natural cosmic variability. In the ever-unfolding drama of the cosmos, recent events surrounding 3I/ATLAS have added an extra layer of intrigue and scientific value to its passage through our solar system, particularly the much-anticipated interaction with a coronal mass ejection from the sun that occurred around September 24th to 25th, 2025, just days before the end of the month. Predicted by NASA's Enlil model based on a solar outburst on September 19th, this CME, a massive burst of plasma and magnetic fields ejected from the sun's corona, collided with the interstellar comet, providing astronomers with a rare natural experiment to observe how such high-energy solar phenomena affect cometary bodies from beyond our stellar neighborhood. Initial post-impact observations gathered from ground-based telescopes and space assets like the Hubble and James Webb Space Telescopes indicate that 3I/ATLAS experienced a significant brightening, reportedly increasing its luminosity by up to 40 times in in the immediate aftermath, likely due to the enhanced outgassing triggered by the influx of solar particles stripping away surface layers and exciting the comet's volatile ices. This event has not only enhanced the comet's visibility in its final observable days before solar conjunction, but also yielded invaluable data on its composition, revealing higher than expected levels of water vapor and carbon monoxide in its coma, which could offer clues about the chemical makeup of its originating star system and the processes that govern interstellar travelers. Scientists are eagerly analyzing the spectral shifts and tail dynamics post-CME, noting how the magnetic fields intertwined with the comet's ion tail, creating temporary distortions that resemble auroral displays on a cosmic scale, further emphasizing the dynamic interplay between solar activity and visiting objects. As 3I/ATLAS fades from view by late September, slipping behind the sun's glare, this interaction serves as a poignant reminder of the sun's dominant role in shaping the behavior of all bodies within its heliosphere, even those hailing from the distant voids between stars, and it underscores the importance of continued monitoring with multi-wavelength observatories to capture such fleeting moments that enrich our understanding of the universe's interconnectedness. Looking ahead to October 2025, the night skies promise an escalating spectacle as C/2025 R2 Swan reaches its peak visibility, potentially brightening to a magnitude of around 5 to 6 during its closest approach to Earth between October 12th and 20, a period when it will be positioned favorably for observers in both hemispheres, particularly in the evening twilight where its greenish coma and extended tail could become a highlight for stargazers equipped with binoculars or small telescopes. Current brightness estimates as of September 30th place SWAN at approximately magnitude 6.5 to 6.7, with recent observations indicating a steady, if not rapid, fade following its perihelion on September 12th. Yet optimistic models suggest that forward scattering of sunlight through its dust tail might enhance its apparent luminosity during the mid-October window, making it borderline visible to the naked eye under pristine, dark sky conditions far from urban light pollution. Concurrently, the emergence of comet C/2025 A6 Lemon as a morning sky object adds to the month's celestial bounty, with predictions forecasting it to reach magnitude 3 or brighter by late October into November, its potential green glow rivaling that of SWAN and offering dual comet viewing opportunities that haven't been seen since the great comets of the early 2020s. Astronomers are also keeping a watchful eye on C/2025 K1A TLAS, another faint but intriguing comet in the autumn skies, though it remains too dim for casual observation, requiring larger apertures to discern its subtle features. The alignment of these comets with meteor showers, like the Orionids peaking around October 21st and the Taurids in early November, could create composite sky events, where shooting stars streak across the backdrop of cometary tails, inspiring amateur photographers and professional researchers alike to document these transient displays. As SWAN threads its way past inner planets, its trajectory will be scrutinized for any perturbations that might refine its long-period orbit calculations, potentially revealing more about the Oort cloud structure and the gravitational influences that occasionally hurl such icy behemoths inward, while 3I/ATLAS, emerging from solar conjunction in November, might offer post-perihelion insights into how its interstellar journey has been altered by our sun's embrace. The simultaneous presence of SWAN and 3I/ATLAS, amplified by the recent CME event and the promise of October's multi-comet display, has ignited a worldwide surge in public interest and engagement with astronomy, transforming what could have been niche scientific observations into a cultural phenomenon that bridges generations and continents in a shared gaze toward the heavens. Social media platforms buzz with user-submitted images and videos of SWAN's tail arching across twilight skies, from the deserts of Australia to the mountains of South America, where communities gather for viewing parties equipped with telescopes and apps that track real-time positions, fostering a sense of global unity in the face of cosmic wonder. Educational institutions have capitalized on this momentum, launching outreach programs that explain the science behind cometary activity, interstellar origins, and solar interactions, with virtual reality simulations allowing students to fly alongside 3I 3I/ATLAS during its CME encounter, visualizing the plasma waves and particle bombardments that led to its dramatic brightening. Media coverage, from documentaries exploring Avi Loeb's theories on potential technological artifacts to live streams of observatory feeds, has demystified complex concepts like hyperbolic orbits and spectral analysis, making them accessible to lay audiences and sparking debates on humanity's place in the universe. Meanwhile, the speculation surrounding these objects, ranging from benign natural explanations to fanciful notions of alien probes, has stimulated interdisciplinary discussions, drawing in historians, philosophers, and artists who reinterpret ancient myths through the lens of modern discoveries, perhaps even inspiring new works of literature and film that capture the emotional resonance of these fleeting visitors. As October unfolds, initiatives like International Comet Watching Challenges encourage participation from all walks of life, with prizes for best citizen science contributions, ultimately democratizing astronomy and reminding us that the night sky is a shared heritage, capable of evoking profound curiosity, humility, and inspiration in an increasingly divided world. In the grand tapestry of existence, the appearances of SWAN and 3I/ATLAS serve as poignant reminders of our humble position within an immense, ever-evolving universe teeming with motion and mystery. These events evoke a profound emotional resonance, tapping into our innate curiosities and primal fears, much like the simple act of stargazing did for our forebears, fostering a sense of connection to something greater than ourselves. Whether viewed as unremarkable chunks of primordial material or harbingers of extraterrestrial secrets, their presence compels us to reflect on the fragility of our knowledge and the boundless potential for new revelations. The what-if scenarios, ranging from benign natural phenomena to speculative technological artifacts, fuel our imagination, encouraging ongoing vigilance and exploration. What are your personal beliefs about these visitors? Mere coincidences sculpted by chance, or perhaps subtle messages etched in the fabric of the cosmos? I invite you to share your insights and theories in the comments below. Subscribe to stay updated on more enthralling cosmic narratives, and pass this story along to friends and family to kindle their own sense of wonder. Together, let's maintain our gaze upward, for the stars hold countless more tales waiting to be uncovered, and who knows what the next glance might reveal in the infinite expanse above.